In this video, I'm going to take a deep dive into the parameters for the Ocean Spectrum node and try to explain them in as much detail as I can. I'm going to go over the wind amplitude, wind instancing, and mass tabs along with all the parameters within these tabs. The top parameters in the Ocean Spectrum will not be discussed in this video. I chose to focus the video on the parameters in the tabs because they aren't as intuitive. This video assumes you have knowledge on how to set up a basic ocean with Houdini's ocean nodes. As long as you know the very basic setup like this one, you're fine. If this is completely new to you, you can check out my other video that does an introduction to ocean nodes titled How to Generate Oceans in Houdini for Beginners. A link will be posted in the description below. So let's start with the wind tab. The direction will define where most of the waves are moving toward. This basically defines where the wind is blowing toward. So as you can see, as I change the direction parameter, the waves move in a different direction. Okay, let's change this back. The speed parameter is actually the speed of the wind and not the speed of the waves. If you want to tweak the speed of the wave, you need to use the time scale. So if I increase this, you can see that the waves move a lot faster. If you increase the speed parameter, it'll increase the wind speed, and the waves that are already being picked up by the wind will be affected with greater wind speed. So let's increase this. As you can see, these waves are more exaggerated. You'll start to see the waves that are aligned with the wind be affected, and the effect of this parameter becomes more apparent on the waves that are already being picked up by the wind. Putting this back down, you can see everything's more calm because the wind influence isn't as fast, so there's less wind speed being picked up by the waves. Directional bias is the amount of waves that are moving in line with the wind. Increasing this parameter will cause more waves moving in the same direction. So you'll start to see more waves moving in the same direction. It'll look more uniform. If we decrease this, so decreasing the parameter will lower the amount of waves following the wind, thus lowering the wind's influence on the number of waves. You'll start to see a more chaotic behavior with the waves, like a storm on the ocean. So the directional bias affects the number of waves that are being picked up by the wind. Directional movement is the strength of the directional bias. Sort of. It's the strength of the influence of the directional bias. So when you increase the directional movement, it'll increase the strength of the wind on waves that are aligned with the wind, which are the waves that were selected by the directional bias. So I'm gonna increase this as well. Just to hopefully get a more exaggerated look so you can see the difference. So when you increase the directional bias, you'll get more waves moving in the same direction as the wind, and you'll increase the directional movement. These selected waves that you select from the directional bias will move with greater force. The movement will be more exaggerated. So let's decrease this. So it's more chaotic because there's less influence on the waves that are being picked up by the wind. So let's make this half. So the directional bias will select the number of waves being influenced by the wind. So if we go 0, there's like almost no waves affected. Well, there are some. There are almost like very little waves, or very low number of waves are being affected by the wind. So this is a lot of the waves are being affected by the wind. That's why it's moving more uniform. All the waves are moving in the same direction. as the wind. This will increase the power of the influence of those waves that are aligned with the wind to move more exaggerated. So the waves, you can see the waves, the effect is very subtle. You can see the waves that are moving, or being carried by the wind, travel a little further. As opposed, when I go to 0, it becomes really chaotic because the strength of the influence of the wave is greatly reduced. Chop will define how sharp the waves will be. It'll make the cusp angle more sharper on the wave, which is the top tip of the wave. So if we increase this, you'll see that these waves are more sharper. So I'm gonna make this half. So you can see these waves. Let's try it at a different angle. It's a little sharper. I'll keep increasing this. There, you're starting to see these little, the tip of the wave become more pointy. So I'll lower this to nothing, and it's more smoothed out. When I lower the chop, the waves become smoothed out. So the direction and speed defines the wind behavior. And the last 3 parameters on the wind tab, directional bias, directional movement, and chop, define how the wind affects the waves. Okay, let's move on to the amplitude tab. So normalize, you usually don't have to adjust unless something terribly goes wrong. So I'm gonna turn it off so you can see. Like, if you see something like this, then try enabling the normalize tab. The average of all the height of the waves, and it tries to normalize it to a decent unit. So the reference wind is the threshold of the normalization. So you usually don't have to touch these two unless something like that goes. The scale is the height of the waves. So if we increase this, you'll see that the waves get larger and larger and larger. The random distribution defines how the height of the waves are distributed. Which wave is what height? What kind of distribution do you want to use? Well, it's randomized, but how do you want to randomize it? Using which algorithm? So this is very uniform. This is very uniform and is very predictable. If you want more randomizing, so the minimum wavelength is the minimum cutoff for the height of the waves that you don't want to see. So if I start increasing this, you'll see some of the smaller waves get smoothed out. And only the larger waves get left behind. The filter above resolution and filter below resolution sort of do the same thing, except it defines the upper top threshold. So if I go like 8, let's see, let's try a number, there you go. It'll start to smooth out the larger waves. So if I increase this, it'll start to smooth out the smaller waves. So there's nothing. The amplitude ramp remaps the height of ocean waves by their frequency. So the left side of this ramp refers to lower frequency waves, and the right side of the ramp refers to higher frequency waves. It goes from left to right on the ramp, lower frequencies on the left, and gradually increases to higher frequencies on the right. Now, I've noticed that the lower frequency waves are always the smaller waves. The higher frequency waves tend to affect the larger waves. According to Houdini's documentation, frequency is the angular frequency of each wave. So the angular frequency of an ocean wave would be the circular motion of water. As the wind pushes the ocean forward, the water moves in a circular motion, pushing it sort of rolls to give you that tidal wave at the top. It sort of pushes it up and then it comes back down. So there's a circular motion as it pushes the wave forward. That's my 30-second attempt into trying to explain what the angular frequency of an ocean wave. The trochoid, I'm so sorry if I butchered this term. The trochoid motion of ocean water waves is the circular motion of water caused by the wave. So I'm going to post a link to a website that'll explain this science and math behind the shape and motion of ocean waves. You don't need to understand all this to make the ocean spectrum work, but if you're interested, you can give that a light reading. I'm going to move both these points up. And I want to try and lower this node over here, the higher frequency waves. I'm going to lower the amplitude. Now all the waves are more smoothed out now. Most of the waves overall, the height has gone down for the larger waves. It would probably be more apparent if I put it on the side. If I increase it back up again, you'll see that the overall height of most of the waves, they moved up. And if I lower it back down, the overall height of most of the waves are pushed back down. Okay, now I'm going to try and lower the amplitude of the lower frequency waves. Oh, okay, let's zoom in for this one. Now there's a lot of smaller waves on top of the larger waves. So if we zoom in, let's focus on this one. Let's move this back up. So there's one large wave here. And there's like these smaller noise that look like noise, but they're like mini waves. If I lower it, if you look carefully, if you focus on just one small wave, you'll see that the bottom of the wave is pushed down as I lower this node. So I'm going to raise it back up again. So this part is sort of pushed back up. Lower it again. It pushes it down. My suspicion that this part pushes up as I lower this node down, the larger wave gets more pointy. It sort of pushes it up as this goes down. I think the ocean spectrum is trying to maintain this curvature for the larger wave. As I push the mini waves down, it sort of gives it a deep curve here, and it's trying to maintain this curve. Thus, this point goes up as a result. So if I go up, then I'm going to raising the height of the lower frequency waves. So these small ones kind of come up a bit, and then it kind of gets a better overall height of all the waves. However, if I lower this, now it pushes the larger wave up. Let's lower the larger wave. So the larger wave comes back down. So that larger wave comes back down and normalizes this curvature. I think the ocean spectrum is trying to maintain this curvature at all times. For the wave instancing, it's randomizing these properties, these values under here. I'm going to do a very quick setup of the ocean just to illustrate what the wave instancing can do. Grid. So this is our grid. Scatter points. Now I don't want that many points. I just 100, and it'll be randomized. So these are the points. Feed this into this wave instancing. Let's see what it looks like. So that's what it looks like right now. The ocean spectrum create new waves out of these scattered points. Now, these waves, these new waves created from these points, are assigned. Well, every wave has different properties. It has an amplitude property, it has rotation, it has radius. It has all sorts of properties that go with it, as we have seen here. These tabs, the wind tab, the amplitude tab, they all affect the shape and orientation of all the waves. The wind and amplitude tabs are forces acting on the ocean waves to define their shape. The wave instancing tab defines what the waves begin with, are instantiated with, these properties to give it the shape. That's very big now. Okay. So I increased the size of the display. This is only affecting the viewport. These are the points that I scattered onto the grid. I reduced it to 10 just so you can see it. And this, if I lower the amplitude, you'll see that the waves disappear because the amplitude, the height of the waves is 0 now. But if I increase it, these ones will increase a lot. So the parameters under the wave instancing, the radius, rotation, amplitude, offset. Now these parameters and the variance, these parameters all drive the ocean wave spectrum node. If we look inside this ocean spectrum node, so we have to unlock it and then go in. This is quite overwhelming, but I'm just gonna show you the beginning part just to get you an idea of how those parameters drive the ocean spectrum. Houdini is using these attribute randomize. So it's just randomizing parameters. Basically, that's what you give it an attribute and a value to begin with, and it will randomize within a certain range that you specify. So if we take a look at the amplitude is 0.8, the variance is 0.2. So if we go in, it drives this these values, these green highlighted values here. Point amplitude minus point amplitude variance. So that was the 0.8 minus the 0.5, I believe. 0.8 minus 0.2, sorry. 0.8 minus 0.2. That gives you 0.6. So 0.8, that's this guy, minus 0.2 will give you 0.6. It's driving this number. And this is 0.8 plus 0.2 will give you 1. 0.8 is the amplitude midpoint that we've chosen, plus or minus the variance of 0.2. So 0.8 is the midpoint between 0.6 and 0.1. So that's the range that we want. And this attribute is, this random attribute randomize is giving us a number in between that range. Randomizing these values will give us variance in our waves. So that's what this wave instancing is doing. It is randomizing these parameters, these properties of the waves in this ocean spectrum. Variance will be a plus or minus of this parameter, of the respective parameter. So 5, it will be plus or minus 20. Let's move on to mask. Here we can add noise, which will create these calm areas in our ocean. So if we play it, So now the waves are not hitting these noises. What's great about these calm areas is that they move with the animation of the ocean. So it's not just one spot, one static spot. So you can see this calm area, it's sort of moving with the ocean. As for this, is the type is for the input that you put in here. So you can actually specify the masking areas with a VDB. To illustrate the mask, I had to open up a different HIP file. So here we have a mask that I created. So this is my ocean. The grid is my ocean. And that cylinder there will be my mask. So I don't want any waves to be affected in that area. This cylinder is just a simple polygon. There's nothing to it. You take the polygon and you have to convert it to a VDB in order to get the SDF. So it has to be a fog VDB. Then it's probably good to cache it if you're animating the mask. So I'm taking the mask and it actually grows. So it grows bigger and bigger and bigger and bigger for an effect. My SDF is being animated. It's a good idea to cache it because it does take a while to calculate the VDB on every single frame. So let's take a look. And after you have everything hooked up and all the masks, so this is the resulting effect. I'm just going to drag this by hand because it's too slow. As you can see, there's nothing in the middle. There's no waves being generated where the mask is present. This video took forever to record. I really hope this helped someone out there, even if it's just one person. Thanks for watching and sticking to the end.